Good morning, grade 8. Now, inshallah, we are going to study the third lesson in light module, which is called Refraction and Lenses. And we studied before that the light has different properties as number one, light travels in a straight line, number two, light reflection that we studied before in the last lesson, and now we are going to study inshallah light refraction. Okay, so first, before studying light refraction, we are going to know some information and some question about refraction and lenses. Okay, first, okay, listen. This camera lens can make an image larger or smaller. How does a lens affect the size of an image? Okay, after that, you can answer this. You can answer this question. Okay, first, when a lens is moved back and forth, an image will become bigger or smaller but will always remain sharp. Or the shape of the lens doesn't matter because light always passes straight through transparent object. The size of the image depends on the diameter of the lens, or the size of the image depends on the shape of the lens. Okay, I think that the size of the image depends on the diameter of the lens. At the end of lesson, we are going to know the best answer. Okay, so after that, listen please to the phenomena refraction and lenses. Okay, refraction and lenses. Why does the polar bear's body look different in the water? Okay, look at the body of this polar bear, and this is the body of it, but this is inside the water. Okay, why? Okay, your teacher will provide you with some pieces of shapes glass. Use the glass to find other ways that light can interact with matter. Okay, you can draw by yourself. Okay, after watching this video, okay, to observe what happens when the bodies are found inside the water. Okay, observe what happens in this video. Observe what happened to this plant by adding water to it in this beaker. And this animal, observe its shape, what happens to it. And look at this beaker, small beaker, inside a bigger one, and adding some oil. But the smaller one doesn't disappear. Observe what happens. So it's a present, okay, not disappear. This video will explain. This video will explain what happens as light refraction. Okay, how can we explain this phenomena of light? Listen to me please.
Explain the phenomenon. You may have noticed that a drinking straw appears to bend in a glass of water. You may have also noticed that lenses can make objects appear larger or smaller. These phenomena are related. What makes the polar bear's body look different in the water? Make a claim about what changes the polar bear's appearance in the water.
So, what do you observe? You may have noticed that a drinking straw appears to bend in a glass of water. You may have also noticed that lenses can make objects appear larger or smaller. These phenomena are related. What makes the polar bear's body look different in water? Okay, make a claim about what changes the polar bear appearance in the water. Okay, write your claim as you work through this lesson, then return to these pages to record your evidence. Okay, one by one. Okay, at the end of this lesson, we are going to answer this question. Okay, so come to explain this phenomena respectively. Okay, what happens when light passes through a medium other than air? Think about swimming in a pool. Have you ever noticed that the light at the bottom of the pool makes a pattern based on how the water is moving? Light is transmitted through the water. Does the light bend with water? Let's investigate. Get this coin inside the beaker containing water and another wooden skewer. Read and complete a lab safety from. Fill a large beaker with water. Hold a coin on one side of the beaker and observe the coin through the water. Okay, what happens? Place the coin in the beaker of water. Observe the coin from above. With your wooden skewer, try to touch the coin from above. Record your observation in the data and observation section. Follow your teacher's instructions for proper cleanup. Okay. What's your observation? Okay, you can record your observation here. Model what you think is happening to the transmitted light waves as it moves from coin to your eyes. After that, we are going to move to another slide, that what happens when light passes through a medium other than air. Okay, what happens? Medium interaction. Have you ever tried to pick up something from a bottom of a container of water and the object was deeper than you thought it was? This happens because when light waves are transmitted, they can change direction. Light always travels through empty space at the same speed, 300,000 km per second. Light travels more slowly through a medium such as air, glass, or water. The particles of the material interact with the light waves and slow them down. Some substances, such as air, only slow light a small amount. Others, such as glass, slow the light more. Refraction of light. What's meant by refraction? Okay, what's meant by refraction? Because of the speed of light changes, as light speed changes from one medium to another. So, as it transmits from one medium to another, the direction of the light will change as the particles of this medium that light travels through. If light enters the new medium at an angle, the wave will change its direction. Okay, as example, small example. If you ride small bike, okay, and move it, okay, on the land, then suddenly you must move in a sandy floor. Okay, what happens to direction of the bicycle and the speed? What happens? Yes, I think that the direction of the bicycle will change and its speed will decrease. Why? Because bicycle changes its movement from a floor, okay, to a sandy one. So the particles of floor or land as ceramic differ from the sand as the particles are changed. So the speed of light as by same this way will change, and its direction also will change by changing from one medium to another. So it's called refraction. Okay, to complete the change in direction of wave as it changes speed while moving from one medium to another is called refraction. It's called what? Refraction. So what's meant by refraction? Refraction is the change in the direction of a wave as it changes speed in moving from one medium to another. So it's called refraction. Refraction. Okay? For example, when you visit an aquarium, okay, the light bounces off the fish and to your eye. However, when the light is transmitted from the water to the air, it changes direction. You always see the fish further away than the fish actually is. This means unless the fish is out of the water, you can only see a virtual image of the fish. Okay? After that, what's meant by index of refraction? Index of refraction. Okay? Observe, each transparent material has a property called the index of refraction, as shown in the table. A medium that has a high index of refraction is sometimes called slow because light moves more slowly through it. A medium that has a relatively low index of refraction, such as air, is called fast. When light is transmitted between two materials, the angle light refracts is dependent on the differences between the indexes of refraction of the two objects. If the index of refraction is the same way, the light will not refract, as when light moves from air to air as it moves in the same medium, so there is no refraction. But the refraction is produced when light moves from one transparent medium to another one. As example, it transfers from air to water and vice versa, from air to glass and vice versa. So it will be refraction. Okay, as material vacuum, index of refraction is 1, wave speed 300,000 kilometer per second. In air 1, okay, in water 1.3, in glass 1.5, and the speed differ from one medium to another, okay, due to the presence of the particles of the medium. Slower media. What's meant by slower medium? Suppose you roll a toy car across a table straight at a piece of fabric. The front tires of the car slow down when they hit the fabric. The car continues to move in a straight line, but more slowly. If you roll the car at an angle, one of the front tires will hit the fabric before the other. That side of the car will slow down. but the rest of the car will continue at the same speed until the other tire hits the fabric. This will cause the car to turn and change direction. A light wave behaves in a similar way when it moves into a slower medium as shown in the figure. Recall that the normal is a line perpendicular to a surface. As light moves into a slower medium at an angle, it changes direction towards the normal. Okay, it's called slower medium. This is the direction. Okay, as this air, this glass, this air. So when light moves from air to glass, it will refract at a change in the speed of light, at a change in the direction. Okay, so it will move from glass to air again, so it will change in its speed and direction. Okay, so faster media. What happens? What happens when light in the figure moves back into the air? Suppose you ride your bike from a sidewalk into a muddy field and then back onto a sidewalk. You use the same energy to pedal the whole time, but you move more slowly in the mud. When you move back onto the sidewalk, you speed up. Similarly, as light moves into a medium with a lower index of refraction, it speeds up. The wave is still at an angle, so the part that leaves slower medium first speeds up sooner. This causes the wave to turn away from the normal. Okay, at this. Understand? So we are going to stop at page 6 and we are going to complete inshallah in next time. Okay, thanks, grade 8. Good luck and goodbye.